In this video, we're going to look at the relationship between the x-coordinate and its corresponding y-coordinate. In the first example, we're given the graph f of x equals to 2x. In the table, I've selected a few x values and then worked out the corresponding y-coordinate. So we see that when x is negative 3, and if we substitute negative 3 into 2x, we get that y is negative 6. Negative 3 times 2 gives me negative 6. When x is negative 2, I get y is negative 4. When x is negative 1, I get y is negative 2. When x is 0, y is 0. When x is 1, y is 2. And when x is 2, y is 4. So looking at this relationship, we see that every x value has a distinct y coordinate. And when this happens, we call this one-to-one mapping. Graphically, we have the graph of y equals to 2x, and we have the axis of symmetry y equals to x. The inverse of the graph y equals to 2x is y equals to a half of x. We're going to conduct a vertical line test. So we take a vertical line and we sweep it across the Cartesian plane. If it cuts my function at one point only, or if it cuts my graph rather at one point only, my graph is a function. So you can see y equals to 2x is a function, and the inverse y equals to half of x is also a function. The second test is the horizontal line test. And if the horizontal line is swept across the Cartesian plane, so if I move the horizontal line up and down my Cartesian plane, and if it cuts my graph at one point only, then that graph has a one-to-one function. And you can clearly see that y equals to 2x is a one-to-one function. So if a graph is a one-to-one function, then its inverse will also be a function. And this is evident that y equals to half of x is a function. And if the inverse is a function, then we may write the inverse using the notation that the inverse of f of x equals to a half x. In example 2, I have the function f of x equals to x squared, and once again I'm going to choose certain x values. So let x be negative 2. So these are my x values, and that will be my y coordinate. X is negative 1, 0, 1, 2, and 3. When x is negative 2, I see that y is 4. When x is negative 1, y is 1. X is 0, y is 0. When x is 1, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So we're going to once again use the shapes to identify the relationship between the x and the y coordinate. So my x values are negative 2, negative 1, 0, 1, 2. So when x is negative 2, y is 4. When x is negative 1, y is 1. When x is 0, y is 0. When x is 1, y is 4, but I'm not going to when x is 1, y will be 1, but I'm not going to rewrite it. When x is 2, y will be 4, I'm not going to rewrite it. And when x is 3, y will be 9, but I haven't included 3 in this table. Right, so let's look at the relationship between the x and the y coordinate. Can you see that an x value of negative 2 and an x value of 2 gives you the same y coordinate? An x value of negative 1 and an x value of 1 gives you the same y coordinate. Then when x is 0, we see that y is 0. We call this many-to-one mapping. So I've drawn the graph of y equals to x squared. And we see that the parabola has a many-to-one mapping. Let's just recall. When x is 1, y is 1. And when x is negative 1, y is 1. So two x values gives you the same y coordinate. If we reflect the parabola in the line y equals to x, we get the inverse of the parabola, which is the graph y equals to plus or minus the square root of x. Right, so we're going to do the vertical line test. Remember, the vertical line test will tell you whether your graph is a function or not. So the red graph, the parabola, if I sweep the vertical line across the parabola, I see it cuts my parabola in one place only, so my parabola is a function. However, when I look at the inverse of the parabola, I see it is not a function because my vertical line will cut my parabola in two places. The second test is the horizontal line test, and the horizontal line test will tell you whether a function is a one-to-one function. So if the horizontal line cuts your graph at one point only, then it's a one-to-one function. Clearly, you can see that the parabola is not a one-to-one function because the horizontal line is cutting your parabola in two places. So the parabola is a many-to-one function. And if your graph is not a one-to-one function, then its inverse will not be a function. And as we have discussed in example 3, for us to have a inverse that is a function, we would then need to restrict the domain, and the point where we restrict the domain would be at the turning point.